Okay, this is the final structure that I'm going to introduce in relationship to this program called mystery word. And here's what I would like to fix. Right now, this game has been set up so that you're guessing this mystery word, and if you get it right, it says you win, and then it sets this Boolean play to false, and basically this while loop stops. It stops executing, and then it comes down here to this. If there was a line of code down here, it would run that line of code below there. That's where the flow of the program would go to the line right after the while loop or while statement. Well, that's great, but you know what? At a certain point, you keep guessing and guessing and guessing. You never get it right. So we're going to introduce compound Boolean statements. Right now, our Boolean here, while play, is just one Boolean by itself, and we're going to combine Booleans so that we can create a condition where there's actually two ways we can stop. One of the ways we stop is you get it right, yay, you win. The other one is you keep trying and trying and trying, and let's say you've tried like 3 times or 4 times and you're still not getting it right. At a certain point, we're just going to say, well, that's enough, right? So to do that, I'm going to introduce an integer variable in my program. So I'm going to say int, and I'm going to call it numg for number of guesses, and I'm going to set it equal to 0. I've made 0 guesses. Actually, you know what? Going into this, where I'm going to change numg, I will have made 1 guess by the time this gets updated. So I'm going to say I've made 1 guess. So here's what I'm going to say. While play and, so this is how I combine 2 Booleans. There's 2 ways to do it, and or. And both and or will be explained in the summary, but right now I'm just going to talk about the and. In order for this condition to be met, both play has to be go, and I want to say that the number of guesses has to be less than 4. So play has to be go, meaning that you haven't guessed the word yet, and the number of guesses is less than 4. If either one of those conditions is false, this while loop will not execute, and the program will pick up right down here below. So let's try this. A couple more modifications I just realized I have to make is one of them is if I'm wrong, I need to increase my number of guesses by 1. So right here, you know what, I don't really care about if I'm right. I'm going to end anyway, so I'm not going to increase my guesses there. But right here, if I'm wrong and it says try again, I'm going to say that the number of guesses I've made equals the number of guesses I've made plus 1 more. So notice this closely, right? This is how I accumulate things. If the number of guesses starts out at 1, when this line of codes run, it says, hey, number of guesses is currently 1, add 1 to that, so it's now 2, and store that into the number of guesses. So now it's 2. If I come to this line of code again, it says, hey, number of guesses is currently 2, add 1 to that, and then store that value into number of guesses. So now it's 3. And then hey, number of guesses is 3, 3 plus 1 more, that's 4 guesses, store that into there, and now you're at 4. I lost track, I'm sorry. But the point is that every single time this line of code goes, right, I'm taking what number of guesses current value is, and I'm just increasing that by 1, and then I'm storing that back into number of guesses. I'm replacing the value that's in there. So let's go ahead and run this and see if this works as advertised. So I'm going to compile it, and I'm going to go ahead and run it. So let's see, guess the mystery word. I'm going to say the mystery word is 1. No. 2. No. 3. No. Ooh, that's interesting because look at this. It says try again, but it stopped. It's not going to let me try again, is it? So that only let me do 3 guesses. Let me come back here and look at this. If guesses starts at 1, keep guessing, the number of guesses is less than 4. Maybe I should set this to 0. Let me give this a try, because I'm trying to make sure, I want to make sure that they're getting to guess 4 times, and right now they could only guess 3 times. So let's try this again. Okay, so I'm going to say 1 guess, 2, 3, Okay, that did stop the program. Here's the thing I don't like about this, and maybe it's something that I'll have you fix. I don't like it that it says try again. It should probably say something like, hey, you've tried a lot, right? I'm sorry it didn't work out for you. But instead it just keeps saying try again, and maybe it should say something different on that one last time. So let's try and see if we get it right what happens. So let's see, void go. So I'm going to say B, okay, guess again, Hornet, hornet, guess again. I better get it right this time. Let's see, WOLF. You win, huh? So I got it in 1, 2, my third guess. You win. You win in blank guesses. I don't know. Anyways, that's pretty much a compound Boolean statement. It allows me to do a little bit more with Booleans than before, and there's two things. There's and then the other structure is or. So to summarize, we've looked at compound Boolean statements, and compound Boolean statements require several Booleans, and they're strung together, and it can actually be a lot more complex than the example that we looked at. But basically, there's a couple things we do with them. We use compound Booleans anywhere that a Boolean is required. So in this case, you probably should think about, hey, if statement, which we didn't use it, but in an if statement, a Boolean is required. So you could put a compound Boolean there also, and then if the right conditions exist, right, it would trigger and run the code for true or else the false code. Another place that you can use them, and this is where we used them in our example, we used them for a while statement. And basically, we had a compound Boolean here. While the compound Boolean was true, we continued to loop through this code, and as soon as it wasn't true, we stopped. So we can use them anywhere that a regular Boolean is used. Compound Booleans allow us to craft more complex expressions and give us greater control over the flow of our programs. And is written with the A right here. You can see it. I don't even know what the name of amperands, whatever, but it's A and then and B. In order for an and compound Boolean to be true, both of the statements have to be true, both A and B. For example, I said, I told my son, you must wash the dishes and fold your laundry before you can go play the paintball, right? So both of those have to happen before the conditions met and the Boolean is true. An or statement looks like this. It's like A or B, and it looks like parallel lines. And you'll see that on your keyboard. It's shift, like somewhere near above the enter key, so find that. But at least one of the Booleans, A, B, or both A and B. So it says at least one, not exactly one. So A can be true, B can be true, or both A and B can be true in order for that compound Boolean statement to be true. Anyways, that's an introduction to compound Booleans. We've got our and we've got our or.